Okay.
All right.
Hello.
All right. Hello, everybody. We're going to get this show on the road. If everybody could find your seats, lower your voices. It is time. I will ask this once, and I will only ask this once. How is everybody doing tonight? That was good. That was great. It's a new year, new us, same us, all that jazz. All right. How many first-timers out here tonight? Great. Oh, my God. Love to see it. That's a great crowd of first-timers. Drink responsibly. For all the first-timers and for anybody who needs a refresher after this new year, actually, hold on. My name is Aaron. Who are we? My name is Aaron. This is Michael up here. We got Sam up front. Erica and Jasmine sitting up front. Adam and Brian running the show. Thomas is online running the show. The OG Tracy Becker, the one who started it all, she's probably watching online. She's over with her family back at home. Oh, and also Caleb. Caleb's going to do our astronomy in the news. Our resident astronomy news anchor. Now, for the first timers, in case you might be a little familiar with what's going on, but in case you're not, Michael, what is Astronomy on Tap?
Well, Astronomy on Tap, thank you for asking, is a worldwide phenomenon with locations all across. And Sam is bringing up a good point. We may have to update this figure, but I recently was at the American Astronomical Society conference, and the Astronomy on Tap headquarters, so the original people who set this up over 10 years ago now up in Brooklyn, New York, they had a poster there promoting what we do and the great outreach that has been done over that 10 plus years. And the map looked very much like this. And I forget the exact number, but the amount of events that have happened in any AOT since that first day to now, it's over 1,000. So there's been a lot of events all across the globe, and hopefully more coming up. I know that they just started a location at my undergrad alma mater, so I'm really proud of that. Yay, Ithaca, New York. So us specifically, what makes us special? Well, we're fun, and you see, we're already wooing and cheering and laughing, so there you go. We're interesting. Both talks tonight will be great, varied topics, but very interesting and interactive. You all will get a chance to ask questions to our speakers by texting our phone line, which is just me. And at the end, a chance to win. If you all want to stick around after our program is over, we do trivia, and we have some amazing prizes tonight, including Robert Reeves' donation of the Lunar Orbiter prints. And this is not a drill, folks. These are the second to last batch. We have one more month's worth of these prints before he's out of them. So thank you, Robert, for giving them to us. And it feels like it's been a while. It's been a year since he started. So, and they've gone to great homes. So, and then a few other prizes, including a NASA calendar, the official NASA calendar, not the one you buy online, the official NASA calendar, and a night sky almanac from last year, which you may say, why do I want that? Because it still has good information that lasts eternity. Please follow us on our socials. Oh, it didn't update. I updated the slide. That's fine. We have more there. We also have an email list that the QR code will be there at the break. So now here's Sam with our program this evening.
All right. We have two presentations, as well as astronomy in the news and trivia at the end. I don't want to go into too much detail. Okay. I lost my pointer. Yeah. Look at this guy over here. Isn't he handsome? All right, this was how long ago in years? Man, you look better than the photo, in my opinion. Anyway, Dr. Lee Childers is a senior scientist for the Extremity Trauma and Amputation Center of Excellence at the Center for the Intrepid Brooke Army Medical Center. There was 3 centers in there. His background is in assistive device research and development. He specifically stated that he's not talking to us in an official capacity, but that doesn't mean you can't listen as though he were talking to you in an official capacity. Importantly, he is a member of the San Antonio Astronomical Association and is also an amateur photographer. And last, he says, now I don't quite understand this, he campaigns a 1980 Plymouth Horizon in the 24 Hours of Lemons racing series. Yeah. He can talk about that if you have questions. Well, anyway, so he's presenting on exoplanets in space, and all exoplanets are in space. Okay, we've covered that. Exoskeletons in space, my apologies. And for those of you who are new, we do this thing called a drinking word, where if he says the word, we all cheer, and just like that, yeah. And we also take a nice drink. So what is that drinking word, Lee?
Tonight will be science.
So, okay. It's a good thing we're not science on tap. Okay. All right. Take it away. Laser pointer is laser, and then down is forward.
Down is forward. Awesome. Love it. There we go. Great evening, y'all. Thanks for having me out here. I'm really excited to give this talk today. We're going to throw in a couple sci-fi references, talk about how that my science fiction has told us potential solutions to some of the problems we're having here on challenges we have here on Earth. It's starting with pigs in space because the original concept for the exoskeleton I'm going to talk about was for a pig. They wanted to do a fracture model on a pig because we can't really do them in humans. And they eventually figured out that they could make a really cool exoskeleton for a pig that would be pretty much useless for us. So then they are like, okay, well, look at this Childers guy and get that going on. So exoskeletons in space. And with that, I'm going to talk about a little bit who we are, but we got most of our lab here, a bunch of groups. So thank y'all for coming out. All right. So I'm not a astronomer. I don't study astronomy. I do biomechanics, physiology, and other forms of science. So this is fun for me to try to stretch it out into something completely different. So I'm going to start with kind of who we are at the Center for the Intrepid, kind of what we do, in case there are any other laboratories out there that'd like to do some kind of exchange tours or anything. We're really big on collaboration, understanding how other people are solving some of these challenges, and how there might be some cross-pollination there. Talk about the challenge that we're facing and kind of the basis of this talk, and then talk about how this might have been done for habitable worlds and science fiction. And and then something that might be a little more realistic is Moon and Mars exploration. So I work for the Extremity Trauma and Amputation Center of Excellence, or the EAST, because it's the Department of Defense. We love acronyms. Particularly, I work at the Center for the Intrepid. This was an advanced rehabilitation center built with the small donations of over 600,000 Americans to take care of wounded service members from Iraq and Afghanistan that had severe trauma. And so we focus a lot on kind of prosthetic care, complex limb salvage, and then in about half of the first floor is our nerditarium, which is also called the Military Performance Laboratory, where we get to figure out, how do we solve some of these challenges, do the experiments, and all the fun stuff. And so we're going to start by talking about a problem the military is facing, then tying that back to space exploration. So we do not necessarily expect to be able to evacuate folks as well as we have in past conflicts. They may be stuck days to weeks, and thus they need a way to stay moving, or really bad things are going to fall on them. And so this is a challenge. Lower limb fractures are the most common survivable battlefield injury since World War I. And so it is a major part of the casualty load that we would expect. Each person that has a fracture is traditionally carried on a stretcher, which must be carried by more people that cannot stay on the mission. And so you can if we can take someone that might be stretcher bound and turn them into, say, walking wounded, then we're doing a pretty good job there. And then, NASA's also looked into kind of fracture risk in space. It is fairly low, although I'll caveat that by saying they focus on the femoral neck and vertebral columns, and not necessarily the dynamics of big, heavy, massive limbs being swung into space and hitting things. That's usually where we get kind of the high energy fractures from. But as you can imagine, if you get a fracture out in the middle of nowhere, then you've got a lot of challenges you need to overcome to survive. And even if we do send teams to Mars, we're probably not going to send enough to carry that person back. We need some solutions that can help them get back in the event of some of these medical emergencies. And so, a lot of what we do, a lot of the technology that's been developed was originally thought of in science fiction. And so we'll start that process with the coolest military branch ever, and that is Space Force. Oh man, okay, there you go, Space Force. Boots on the moon. And so they had an episode where they had these medical exoskeletons. They were powered systems. And so they had this Air Force versus the Space Force. They had this little combat deal where they try to pop each other's balloons, and if they were wounded on the battlefield, then the exoskeleton would walk them off. Lots of comedy ensues on that one. So there's a concept there for you. These are powered. Power takes electrons, and they're really negative and not a lot of fun to play with sometimes. They're heavy, they have control systems, they require a lot of power, and so they may not really fit the mass and volume requirements of space exploration. So we can look at other areas that may give us some insight into things. The tropical planet of LV-426 is technically habitable until you run into some aliens. It had a very famous exoskeleton that was great at fighting queen aliens, maybe not be great at evacuating you with a fracture. Star Trek, Deep Space Nine. Melora was a character that grew up on a very low gravity planet. Then she came to Deep Space Nine, was much higher gravity, and they were afraid that the gravity would crush her biology, crush her bones and everything. So they made her an exoskeleton. She spent most of the episode in the wheelchair. She could take some steps with it. It definitely looks cool, and that's about all it does. Just to kind of be more inclusive and complete across our different versions of science fiction, Battlestar Galactica, So Say We All. In one episode, this character, Lieutenant Gaeta, was shot during a mutiny on a spaceship. And that is a very common injury you shot through the tibia. Very common injury that happens in the field. Fortunately, he was on a spaceship, and so he doesn't necessarily have the evacuation challenges. But we do have the challenges of if we send folks out and they do get injured, they may still have to operate inside the spaceship and cannot be laid in bed for long periods of time. Eventually, got to have them all, right? So we have a Star Wars reference in there too. So poor Anakin here got a triple amputation all at once. Apparently he didn't have the high ground. And I don't know why this is advancing like that. Anyway, So bilateral amputations, we can't really do a lot for that person at the moment. That would take a powered system, then we run into all the other challenges, particularly on the control side. And we work with a lot with folks, UT Austin, Georgia Tech, on some of the development of those systems. But what is most applicable to us, and I saw this episode literally as I was getting the proposal done for this exoskeleton, watching The Expanse. This is season 4. Ilios 4 was the planet. Mr. Mercury, I believe, was the person here, a bit on the villainous side. But he did acquire a closed tibia fracture, and he had to kind of keep moving to do all his villainy kind of things on that planet. And so he was fitted with a lower limb exoskeleton for his tibia fracture, which looks remarkably like a commercially available knee brace he just extended. But it was really cool to see like these challenges are going to occur, and we're working on projects that can help mitigate some of those challenges. So what we've come up with is the Intrepid Battlefoot Exoskeleton, or the IBEX. It is okay. It is designed very low mass, very low pack volume. It's a little under 6 pounds. It's about this big, all folded up. You can unfold it, stabilize an open tibia fracture, and get moving again. And so because this is technically a science talk, figured we needed some data. So this is the only figure we have. It is from cadaveric testing. We gave cadaver legs fractures, and then we put different systems on there to, this thing's crazy. We put different systems on there to see how well they could stabilize that fracture. I'm not going to show those videos because we're eating and drinking at the moment, but just trust me, it worked out really well. Our system is the one in blue, external fixator. So this is the kind of gold standard for fracture management after you can see a surgeon, which probably not going to be available to a lot of folks. So not applicable to our situation. One thing we learned about early on in this, and this is with the cadavers, and it was a really gross video, is the whole leg has to be independent of the exoskeletal frame. And the reason is you have this exo on there, you take a step, and you keep going, exoskeleton stands still. Because it's clamped onto soft tissues are squishy, there's a lot of deformation. It's about 1.5 inches. And so you can imagine if you have this large movement of the whole leg moving down relative to the exoskeleton, and you fix the bottom of that fracture, the two bones are going to collide, and it's going to get terrible very fast. So key to know whether you're building things for real or you're improvising them in the field, which is a deal with Southwest. Hey, Dan. But we think that could potentially be a solution for more habitable worlds that we may not necessarily get to visit just yet in the future. But what might be more applicable to us is kind of Moon and Mars missions and explorations. And so now we have a new challenge, is they're in a spacesuit, which you cannot remove if they have a fracture. And so that creates a lot of challenges, particularly for these frame-based exoskeletons like IBEX. Unless you can integrate it with the spacesuit, may not actually work. NASA, a little over 10 years ago, came up with this powered exoskeletal system. It was kind of quasi-designed with the idea that it might be integrated into a spacesuit. They never did that. They ran out of that thing called funding. No problem is unsolvable, it's just low resourced. Anyway, so they came with this. Challenge here is it has no way to isolate movement of that fracture. It's a rigid exoskeleton right down the foot plate, so there's no space underneath the leg to even come up, take up some of that stuff. So this probably isn't going to work out very well for someone on the Mars or Moon. But again, science fiction to the rescue. the classic documentary Demolition Man. We have Sylvester Stallone, crashes his car, and as the car crashes, it fills full of foam and protects him during that collision. And so this actually did inspire U.S. Army development that we're now involved with, and that is using spray foam for fracture management. So you can think of like the great stuff foam for insulation, except it doesn't burn your skin when you put it on your skin, and some other challenges that would not recommend using that for fractures. And this is being commercialized by some of our collaborators now, Triton Systems. We have a grant with them right now. We're adapting their stuff for open tibia fracture and some other things. Should be really interesting. Basically, the foam expands into these chambers, and so it can conform to whatever shape that limb is. You can imagine with blast injury, it probably doesn't look like a leg anymore. And so you need to be able to conform to odd shapes. And then something they've just recently developed that's super cool, can't wait for us to get to play with it, are these blister packs. So instead of having two-part foam, they're in this kind of silicone blister pack. When that gets punctured, the two components mix, and then the foam expands from there really rapidly. Looks really cool. Can't wait to see it. And so I would say that if we could put those around someone's knee joint inside the spacesuit, when that's punctured, the foam's going to expand downward and upward. So as the foam expands downward, it's going to kind of latch onto that foot and pull the foot down and have that fracture and traction, which goes great for relieving pain. The other side is going to go up and create a seat for the pelvis. The whole thing will rigidly harden, and now you can walk on something. Now, there's certainly some challenges to, say, getting out of it when you get back to where you can take the spacesuit off, but one challenge at a time, and if resources were available, I'm sure some people could figure that one out. So to kind of summarize the talk, we've seen exoskeletons in science fiction. It can and has, in some cases, inspired a lot of new technological developments. I would propose that the battlefield is a very austere environment, and we can learn a lot from that environment that could be applied to space exploration. IBEX, or a frame-style system, might be best for habitable worlds where you're not in a spacesuit. But if you're in a spacesuit, probably the spray foam would be the first alternative I can see that's kind of on the horizon. And with that, it takes a big crowd to do this. Now. Oh, man. So I was going to say, it's not just me, it's a whole crew. We have a great laboratory, great support from our Center for the Intrepid Leadership and the Combat Casualty Care Research Program, Department of Defense. We're totally funded by the Department of Defense. And so that's really helped us out through the years. We also have a great collaboration with Dan at Southwest on improvised exoskeleton system. So what can you duct tape in the field versus have something already made? Definitely want to thank the San Antonio SAAA for helping me out with some of the sci-fi references. And we'll just... Yeah.
Well, great talk. And while we work to get this last slide up, we'll start the questions. All right. For an upcoming electrical engineer, what concentration would you recommend if you want to work in exoskeletons in space?
don't know much about exoskeletons and space part, but for exoskeletons in general, the hardware design for powered system, the control systems are particularly challenging. As you can imagine, if you have a motor big enough to move a joint, you have a motor big enough to break a joint. And so those control systems must really be spot on and can be pretty much error-free. And so, mentioned working with Georgia Tech a lot with those systems. And so I would say look up Aaron Young at Georgia Tech. He's got a ton of funding to do powered exo research, and have fun.
Let me see here. The slide is up now for you. What materials do you typically use to make these exoskeletons? Are they consistent? Consistent? I don't know what about that first one.
The IBEX, we do all of our carbon fiber work in-house. The knees are currently titanium. We 3D print those at Walter Reed. That's the majority of it. The rest, the interfaces are just fabric. They have some carbon fiber stays and some other things inside, but they're pretty simple. As far as consistency, like we do make our own carbon laminations. If you've worked with that before, you know there's some variability in stiffness. And so we do a lot of different layup testing, breaking that in our materials testing machine, and then figuring out the variability, and then engineering from there.
Interesting. So on that, keeping on that topic, is there any research into 3D printing, and is there any sort of material that would be robust enough to carry the weight necessary?
Titanium certainly would, but it would take you a while, be fairly expensive. A lot of the, your kind of FDM printers, by the time you print something big enough and thick, strong enough, it's going to be so thick that it's going to be very difficult to use. That's been our experience. We use 3D printing basically to test fit parts before we go to the machine shop, and then we have a Formlabs printer. It has material that can print with the same mechanical properties as human bones, so we use that for a lot of our surrogate leg testing. We'll strain gauge instrument those bones. And then those molds, they're also very high resolution. They can go right in the pre-preg oven, cook them with the carbon, don't have to worry about melting things. So that's pretty much where we use 3D printing in our developments.
Okay, very good. If you had unlimited funding, what problem would you take on?
Oh. Man, so many. I think, I'm a prosthetist, so I fit artificial, or at least I did. Now I do science. And so, going back to kind of prosthetic users and kind of enabling them to the highest function would be a big the challenges that I would solve, and it's that interface between the person's limb and that socket that is the source of all problems. Carbon fiber feet look cool, but they kind of all do the same thing.
How much does an IBEX cost, and can I buy one for after I've been on the toilet too long?
We have not calculated per unit cost yet. Thus far, we've built 7. Lead engineer, Dr. Johnson, we good on 7? We got 6, all right. Man. 7.
I'll sell that for the toilet.
There you go.
And we've gotten about a little over $6 million funding to make those, so divide that, it's expensive.
Yeah. Let's see here. On the last few slides, did you take the photos that were in the background? I think that
Yes.
last one. Yeah.
Yeah.
Oh, yes.
Yeah, so a lot of them is just right in my backyard with narrowband filters. I'll say Robert Reeves' discussion inspired me several years ago on using filters in the light polluted areas, and so I built my own little mini observatory, and I've been doing that ever since. It's hard getting out to dark sky and setting everything up, and yeah.
Very good. Well, let's thank our speaker once again. Thank you, Lee.
Thank y'all.
if you have any further questions, I'm sure he would be happy to answer them while we have our little break. Thank you so much. I'll take this back. We are going to our 10-minute break now, so 7:45 is when we'll resume. Please make sure you just stay in the room if you want to order food at least. You can leave the room to use the restroom or make a phone call, but don't order at the bar. Email list is right there. If you like our event, if you're a first-timer and you like it, sign up for the email list. If you don't like it, sign up for the email list and then email us to complain why you don't like it. Thank you. Yeah. And check out our merch table.
All right, all right, all right. We're moving on to our next section of the night. We're going to have our resident astronomers come up and give us the lowdown of what's happened in the, well, now, I guess the last 2 months, because it's February, everything that's happened in the last 2 months. Too many things have happened in the last couple of months, only the last couple of weeks. But yes, so we're going to have attention. All right, everybody. Thank you. We're moving on to our next section. We're going to have our resident astronomers in the news give us a lowdown of everything in space-related. Caleb and Jasmine, take it away.
Hold on a second. Is that on PowerPoint or is that on? Okay, all right.
Make sure you stand.
Okay. Yeah. Anyway, all right. So, hello again, everyone, and we will go ahead and get started with astronomy news for the month of February 2025. So, first and foremost, the skies at night. So, the February nighttime skies, you are looking at a wintertime sky for the most part. In fact, the constellation of Orion, the mighty hunter, is right in front of you there, best marked by those 3 bright belt stars, and the bright star Betelgeuse and Rigel. Don't say Betelgeuse, one more time at least. Follow the belt of Orion down to the left-hand side, leaves that very bright white star Sirius in the sky. It is the brightest of the nighttime stars. No other star outshines Sirius. And then follow the belt on up to the right-hand side for the evil red eye of Taurus the Bull, Aldebaran. It is very easy to navigate around the wintertime sky. Just use the constellation of Orion. And overall, there is what we call the winter hexagon, a group of stars that form a kind of rough hexagon shape there that are very, very bright, very easy to find. However, scattered amongst these bright stars in the skies of February are the planets. We have a very, very nice month of planetary observing coming up. So right now, if you go outside, starting in the early evening, look west at sunset, you will find the very bright planet Venus over toward the west. And you can't see it in this representation. This is for a little later in the evening, around 8:30 p.m. But if you go out around sunset, around that 6:30, 7 o'clock p.m. time, look just below Venus in the sky. There will be a fairly bright star-like object. That is the planet Saturn. Now, if you look almost straight overhead, you will find for much of the evening the planet Jupiter, very, very well placed. And then if you look more over toward the eastern part of the sky, you will find Mars, a very distinct kind of salmon red-colored star in the sky. You cannot miss it. A few things to look for. If you have a pair of fairly powerful binoculars, and more importantly, a small backyard telescope, if you look at the planet Venus right now, it will look like a small image of the moon almost in the telescope. It actually will show what appears to be phases. We're looking at from its sides. We're able to see its daytime and nighttime sides. As the month goes on, the planet Venus will become more and more crescent-shaped in the field of view of the telescope, so don't miss that. And then for Mars, we have just passed the closest approach with Mars for the next couple of years. So please, go out and get a good look at Mars. If you have a fairly powerful backyard telescope, you will be able to see the polar caps on Mars fairly clearly through the field of view. Now, toward the end of the month, Mercury will join this lineup. Saturn will be very, very low, but Mercury will be just about where Saturn is in the sky. And then you can go through the whole series. And Uranus and Neptune are in that lineup as well, although they are much harder to find. I will leave that up to you if you have a telescope powerful enough to find them, to go out and find where those are. But nonetheless, all of the visible planets will be visible in one evening later on this month. So please do go out and get a look at that. A deep sky object for you. Look for the belt of Orion right underneath the belt. As you find the sword there with the pair of binoculars, you'll find a little fuzzy gray area there. And the pair of binoculars actually may look a little like that in a really dark sky. That is the Orion Nebula, a nice star-forming region about 1,500 light years away. And make sure to find other deep sky sites, many nice open star clusters scattered amongst the band of the Milky Way there in the nighttime sky right now. And with that, I think I'll go ahead and hand it off to Jasmine for the first news stories. So here you go.
All right, I'm gonna try not to go like super long this time. I went too long last time. But first off, it isn't, news without talking about Europa Clipper. So Europa Clipper recently just opened a few of its eyes, not all of them yet. It's still on the way to Jupiter. It won't be there for about 5 years. But the first week of March, we are going to have the Mars flyby, so put that on your calendars. That's going to be really exciting. But we got the first image. This was actually taken back in December, but it was just released yesterday, actually. Using the star tracker on the spacecraft, we got part of the Corvus constellation that we're looking at right there on the left that we can see. So that's really, really awesome, and I'm excited to see the actual image of Europa when we get there in about 2030. All right, now moving on to the commercial sector. So we had mid-January, we had the launch of New Glenn, which was Blue Origin's first rocket launch, right? Something like that. Yeah, first orbital launch, yeah. So really exciting time because now we're kind of expanding our range of spacecraft that we can use. We have Starship that also launched right after this, and then New Glenn, which is, both of them are looking to be promising. So hopefully, we can use them in the future. Okay, and then also in Hubble news, this also happened pretty recently. So Hubble revealed a very unusual quasar inside of a spiral galaxy, which is kind of unusual for quasars. They're not usually detected in spiral galaxies. So this was really weird, actually. I don't know too much about quasars. Sorry, I'm not an astrophysicist, but I know that it raised some questions about quasar formation and quasar formation, because like I said, we don't really see them in spiral galaxies. So that was really interesting. You can see it in the left. Is this the laser? Yeah, you can see it. It's in this galaxy on the left. So yeah, that's the news I have right now.
And so I have a news story I decided to add in on this as well. Just earlier this month, this image set was released from the James Webb Space Telescope. It shows light echoes from a supernova explosion, Cassiopeia A. Now, what on earth do I mean by light echoes? Well, here's what we mean by this. When an event like this happens, of course, light travels across space, reaches us. But not only does it reach us, it also reaches other objects out there. In the case of a very bright supernova explosion like Cassiopeia A, which was observed here sometime in the 1600s, this light will actually start energizing nearby gas, but it takes the light a little bit to reach the nearby gas. And then the illumination from that nearby gas to that star takes a while to reach us. So what we see is essentially the light being re-emitted somewhat later from our perspective than when the supernova was observed to take place in our frame. So you see, of course, all this energized gas around Cassiopeia A there, and a few filaments far out here in the distance that are being energized by that original light. That light echo is constantly being transmitted through this gas, and you actually see that in this time lapse here. This is something very rare. Very rare do you see astronomical phenomena that can actually be imaged, in a human time span observability, all right? In the case of this James Webb imagery, you see that light echo traveling across the gaseous region there. And the JWST was able to pick up roughly 400 astronomical unit in size features here. That's really small to be able to be seen from this 11,000 light year distance. So really, really awesome stuff there. Now for things to keep up with in the coming months. Just earlier this month, the Firefly Blue Ghost 1 lander was launched into space aboard a SpaceX Falcon 9 rocket. It is currently in orbit around the Earth. It will soon be put on a translunar trajectory, and when it reaches the moon, it will orbit around the moon, and it will land on the surface of the moon. This is slated to happen March 2nd, so watch out for that in the news. This is actually an image from the Blue Ghost 1 lander as it's orbiting the Earth. Really pretty imagery. Very, very fantastic imagery. There's a mission called SphereX, slated for launch on February 28th. That is the actual spacecraft itself. It is a near-infrared and optical survey telescope to orbit the Earth and take imagery of the entire sky to be able to understand more of the structure of our galaxy and, more importantly, the entire universe itself. So it's essentially a large-scale cosmology mission. And then finally, earliest February 27th, but I think it's probably going to slip a little later, is Intuitive Machines IM-2. This is Intuitive Machines' second attempt at a lunar landing. Again, that will be likely launched, if not at the end of February, at least in early March, so watch out for that. By the way, both of these companies, Firefly Aerospace, Intuitive Machines, based right here in the great state of Texas. So, Intuitive's over in Houston, Firefly's just a little outside of Austin. So, and some events for you. So do not miss on the UTSA Observatory and San Antonio League of Sidewalk Astronomers side, observing on Friday night at UTSA Observatory coming up, and next Friday night, if you didn't get in on it the previous Friday, at UTSA Observatory as well. Do not miss those. Top floor of the Flown Science Building starts at sunset. Make sure to drop by and see us. And then coming up on March 1st, we will be doing one of our monthly observings out at South Llano River State Park. I had several of my fellow Swery grad students joining me out there last time we did this. It was a wonderful time. Thank you for showing up. Please make your way out there. Beautiful dark skies, can't miss it. And then finally for SAAA, every Wednesday at sunset out Raymond Remkus Park, they're doing observing. And there's actually even more events listed on their website. Please go there and look up their calendar. There's a lot going on. But a couple of highlights, Guadalupe River State Park, observing February 8th. Eisenhower Park, observing February 15th. And then the Scobie Planetarium, they do their planetarium shows every Friday night. Doors open at 6 o'clock, don't miss it. And the first Friday, as AAA, they do the observing there as well. And now I'll go ahead and hand it off to you again to do those last couple of images.
We're going to end off our astronomy news segment with some beautiful images that actually released yesterday. So it was a big day yesterday. So on the left, we have a James Webb image. And this shows a protoplanetary disk around a newly formed star. So basically what you're looking at is a planetary system forming. And it's believed that our solar system formed in a similar fashion. So that's really cool that we're looking at that. And then we have a beautiful Hubble Space Telescope and Keck image of the Bullseye Galaxy. You can see the beautiful, beautiful rings around it, so looks like a bullseye. So yeah, we have some beautiful images for you to look at. Thank you.
And thank you very much. That was Astronomy News.
Thank you, Caleb and Jasmine. Woo! So yeah, that Friday night celestial lights will be on Valentine's Day. So, you know, the sky is full of love. All right, our second and final speaker for the evening is Mark Jurena. Come on up. Okay. Mark is an alumni of UTSA, Go Runners. During the day, Mark teaches engineering students stuff like graphics and mechanics. Mark started in astronomy with his first telescope, an Edmund 3-inch reflector, many years ago. However, his older brother Dwight got more use out of it, including views of the Sombrero Galaxy. Mark was a president of the San Antonio Astronomical Association, SAAA, current parliamentarian of the SAAA, the Star Party chair of the SAAA, as well as a past vice chair of the Southwest region of the Astronomical League. Swirl. Swirl? Oh, swirl. There you go. That makes sense. As well as co-chair of Alcon 2014. Mark enjoys both the clear dark sky and the rainy nights. And, first you wanted me to give you this. A reminder. So I've been informed that it's not a drinking word, folks, so pay attention. It's a drinking phrase.
A bridge too far.
Bridge too far. All right, without further ado.
Yeah, somebody saw my slides. We put the beer down. Okay, put it on the piano. Okay.
Wait, here's the clicker.
He needs the clicker.
Down for advance, and then the bottom is the laser.
You'll figure up. I'm usually the one who has to tell it to everybody. For once, it's nice not to be the one who has to set up the laptop. I do it for the SAAA, and then I have to call to order on top of it. So anyway, there's 3 things I've got to say. Okay, please don't get us banned from Facebook Live. There's another one that shows up here, don't drink and drive. And then no karaoke. We'll get into that later. Okay, the only thing that showed up there, I don't know why you guys put that up there, doctor. It's not honorary, it's honorary. It only happened once. I was doing graduation for Northwest Vista College, and they accidentally gave me doctoral robes. Accidentally. So this is what's funny. They don't know how well they set me up. This is dangerous, I told you guys. So, yes, the back end of an Otto Struve telescope up at McDonald Observatory, so 6,700 feet. That is a surplus shed 38 millimeter Erfel eyepiece, which means it's not the usual stuff, which is expensive Al Nagler, Panoptic, or something else. And this is before they put the focal reducer. So anyway, so anything you get in there is like north of 500 power. Okay, we'll figure this out. Okay, here we go. Yes, I put it MSME-EI-EIO. You know what kind of talk it's going to be. We warned you. I warned some of them. Okay, so it's SAAA. So yeah, Star Party chair. My brother apologizes. Speaking of which, thanks for all of you who are here, who are my peeps. Some of them there. We got Pedro. That's 2 Pedros in one day. Robert, who wanted to have 5 minutes for rebuttal just for my bio. We're talking about my bona fides are no good for him. Who cares? And then Dan's here too, and then we get our other peeps who I helped out for one eclipse. No, we're not talking about the eclipse, Lindsay or Lisa. We're not talking about what happened there. No. What happens there stays there. Oh, we're going to blame Lisa on this one? Of course, the other one who could be on here, I got to thank Dwight on this other one, and of course, thank Angela Speck, because I met her and she talked about the thing. She always say, yeah, you want to depend on amateur astronomers, they will bail. So the other thing is that Robert and I both know, we know where the bodies are buried. Whether it be UTSA, including physics, Texas Star Party, and any other place. And also we had the other thing, because one of the other names, I substituted as president. Actually, was chair one night, and guess what happens? We wind up at EZs. So the name got to be instead of San Antonio Astronomical Association, it became San Antonio Gastronomical Association. And the thing is stuck. Yeah, I'm guilty. So the other thing I got to do is, I do something else. I got one commercial I got to do since I teach at Northwest Vista. So it's funny, and I get the other one. What is my office? It's in the Cedar Elm STEM Center, which I'm looking at. What is the STEM you speak of? And it's 306F, so we're F troop. Anyway, Transfer Academy for Tomorrow's Engineers, so we're connected. We're a big feeder for UTSA, so we get a few engineers up there. Every now and then the guys in physics tell me they get a few others. By the way, I was up last night and with some of the physics guys, and I was tormenting them. We're teaching them how to use telescope. It happened to be a Celestron 6-inch. So we're doing that. Okay, Up there, it's not always lock up. That's on McDonnell Observatory. Always look up San Antonio Astronomical Association. So, Loose Confederation. So we're at 50 years. People are going to go, 50? Yes, I know where the bodies are buried. Our 25th was actually done at Scobie, and this was before, actually it was done at SEC. It wasn't at Scobie. There wasn't much there. So we actually do a lot of stuff. And of course, I'm going to call you guys out on it. For the new one, for y'all, it looks like ours. M51 and a few other things, because M51 has another thing. Why we have it as part of our logo with also Hemisphere Tower and the Alamo is M51 with another little thing, an ARP's peculiar, which will actually come up, is one of our members could not find M51. So consequently, it became part of the logo. Yeah, I told you I know where the bodies are buried. So y'all use this. Okay, what do amateur astronomers do besides wreak havoc? We tend to. Okay, enrichment. We talk about speakers. From a certain point of view, those of you with your advanced degrees, the PhDs, the masters, you call it outreach. For us, call it service. For us as amateurs, we call it enrichment. And the other one that shows up is networking. My SAAA members hate me on this stuff. Even Tracy told me, I didn't know you were a member of the group. I says, we do one thing. I go out for networking. I talk to the others who are at these star parties, so we do a lot of networking. And of course, don't talk to Pontchartrain astronomers about NCIS, or as I want to call it, NCIS Quantum Star Trek. They hate it. It blocks their way. So we don't like them. Edification, what is this? It's a $4 word for, we go through lists. We do them as some people might do equations or something else. They'll work through it and try to get a little bit more. The other one is doing amateur talks. And we'll get to that later. Texas Star Party is full of amateur talks during the day. Usually in the afternoon, people are sleeping in the morning or barely getting their coffee. I ought to know. And then a couple of them go in there. And I had the discussion with some other people on what they do. And one of them says, a lot of the stuff we do is not really citizen science. It's before that. And everybody, the horror. Citizen science? What do you mean, not citizen science? Hey, we own the telescopes, we buy the computers, we pay for the software, we keep the upkeep. They're ours. It's a little bit different. So, kind of get that other one. Okay, or is this all a bridge too far? That's what you do when you teach engineering, you have this. Okay. So I converted some stuff over. I like doing U.S. customary units. Engineers can translate between the two, freewheeling. Everything shows up. So there's a bunch of things. Astronomical League is the first one that comes up. We're going to say that's more list-driven. So Sky Puppy, I know somebody who started Sky Puppy. It's somebody who's up in Albuquerque. Beginners, ARP's peculiar. Yes, I went to a talk by ARP. They'll show up later. Need an 8 to 20-inch telescope. Imaging award, you can get that. Need a camera with a bigger than 8. I haven't messed much with those. Messier and Herschel list. You know, if I actually got my budding gear, I'd have my Herschel list completed. So I get a lot of them at the Texas Star Party. Okay, this is the other one. American, so we're full of acronyms, more than anything in astronomy, I think. So American Association of Variable Star Observers, that actually showed up at they were there for our Astronomical League convention in 2014. So they work with variable stars, and they pick the other thing. I call it the poor man's spectroscope, and it's mostly invisible in the visible region. It has nothing to do with anything else other than where the sensors are. Yes, there's a bunch of stuff. I know there's a bunch of places that it's very opaque because of all the water vapor, and especially if you're dealing at your typical elevations. For us, we're thinking below 1,000 feet and stuff like that. So we have the other stuff, which is, let's say, find the laser pointer. Find that freaking laser. I want a go one. I'm going backwards. We're going backwards, aren't we? Time travel. Oh, there we go. Now I found it. Nope. Time travel. Okay. This is the usual stuff. So I talk about some of these poor person's spectroscope. So the problem with most amateur telescopes, you're doing sub 20 inch. So for the professionals, that means half meter or less. So if we're doing those, we use a bunch of them that are actually out there. So they use the Johnson's Cousins, which was developed at McDonnell Observatory. So they've got the UBVRI. It's not like some other things. So you've got ultraviolet, blue, violet, your red, and then your infrared. The infrared's like a near infrared, so 0.1 micron, and so it's an easy way to do it. So they try to do with all this stuff. Now, part of it, some of them will do it visually, and part of this starts getting into the other part where we say observational astronomy, and it's not the same thing a lot of amateurs think about. A lot of amateurs think about observational astronomy. What do they think about? They're thinking about naked eye, your Mark I eyeball. Not so much. It's more you want to do something else. The spectroscopy is tough to do. Data submitted to that AAVSO website. So a lot of these Johnson Cousins, good stuff to have. Okay, Association of Lunar and Planetary Observers. Yes, it says ALPO. It's not dog food. We don't do the dog food stuff because we're there. So there's 14 sections, so they do everything. Solar, major planets, minor planets, comets, everything else we do. And of course, they have the strolling astronomer, and they have that since 1947. A lot of those started out, the previous one started in 1911, so these are old at this point. Icarus. Okay, and that was something that happened this summer. That's what we would call, y'all know your planetary stuff, it's a fall and a fine. Probably first time ever, because you actually see it. And this was in Prince Edward Island. So if I was doing karaoke, I'd be singing Jimmy Buffett's Portugal or PEI. And it's that kind of a thing. So we look at that. So they do those, and my brother, Meteoritic Society, and it's like, yes, I know. And my brother has the other one, and I'll have to say it. There's actually a conference and other stuff that says asteroids, comets, and meteors. Oh my. So everything else that goes there. Okay, this is the one that I've actually done. Occultations. I've dabbled in the occult. But there's more interesting stories about this than might meet the eye. So we kind of do that. Timing the moon, the planet, and asteroid. Lindemania and Tuttatus. I got a story about Lindemania. Somebody says we had it going in there. Lithuania, no wonder my telescope was pointed wrong. But Tuttatus, I think my brother got more looks at it. It was at Fort McCavitt, way out west. Lindemania, what happens? I'm on the road to Guadalupe River State Park. What the heck happens? Buck snort. I got lost. Couldn't sign. You're thinking, come up with buck fever, especially somebody like me. So didn't do it. And of course, we know a bunch of people, Rick Frankenberger, and of course, Robert Reeves have some people who do that. Paul Malley is somebody else that, didn't you go to school with Paul? Okay, that's same year, okay. We do that. So this is what can be done with these. So what happens is you put yourself on a long baseline. We did the other stuff when we're doing those where we do our favorite thing, we do WWV. Count out that stuff out of Fort Collins, Colorado, does the timing at the tone, 9 hours, 16 minutes, coordinated universal time. And then you hear beep. And so the cheap way or the old way was actually doing it with a tape recorder. These days, you get the video recorders and you can do some good stuff. So real good stuff. Okay, or is this all a bridge too far? So here we go. Yes, Robert, I gotta get a picture of you. And then here's the other one that we have. Who is behind him? Holy cow, Larry Mitchell. He's like the Carolyn Porco of amateur astronomers. Those of you who know who Carolyn Porco is, who are professionals, she's legendary. Yeah, they're shaking their heads for going long, 80 slides in 60 minutes. Larry, it's like, you can do 2 examples. No, I'm going to do 4 and do that. So this is where we all get them out. So the one thing are conventions. I always want to be relabeled. Star Party and Convention Stare. These are serious things. These are 6, 7, 8 day knockdown dragouts. You're tired. You're bizarrely paranoid. You finally got your body chemistry acclimatized because you're drinking enough water instead of just drinking coffee in the morning. And then, of course, we do the other things that show up. And then towards the end of the week, what happens? Giveaways. And we're on the low end of Bloom's taxonomy. We can just be parrots. That's all we're good for. We'll tell you one of them. Okay, so a couple of them. Texas Star Party, I have been. And of course, we've got Angela. I had to put Angela Speck. And of course, Ted Saker. It's like, damn it, can you read copy better? I could do a better job of doing that for the introduction. It was disappointing, especially for alumni of both the department and the school. El Dorado Star Party? Yes, it's El Dorado. El Dorado is a movie with John Wayne, Robert Mitchum, and James Caan as Mississippi. And he sings the song. So it's by the natives, and the town itself looks like it's separated. Nobody stays in the town, they stay elsewhere. And of course, that was somebody else who called me Grand Poobah Speaker Chair. It was somebody else, we'll show you. Deep South Texas Stargaze, that's a defunct star party. It was run by a minister who did it. It was in the Escondido Ranch, which was somewhere near Freer. It was not really that deep, but it was pretty remote. Coyotes were out. Stellafane in Vermont, this is because Dwight's on there. He went to Stellafane. I got to give him back his t-shirt. Winter Star Party in Florida, which is another one that shows up. That's a good one to catch, and it's about this time of year. Same thing with Deep South Texas. Riverside also went away, Telescope Makers Conference. And I talked to somebody one time, and he was at the Riverside in the club, but never did the conference. I was like, that's disappointing. And of course, this is what can happen. I missed something else that's up there. I deleted it. In 95, I signed Clyde Tombaughl's Get Well card at TSP. Okay, here's the other one that shows up. Okay, that's a big daub, probably a Coulter representation. It's got somewhat of a line. This is a water tower. You put a ladder up on it, you'll get a bigger line. That's what we do. You put a big ladder up on there. And the biggest one, okay, Texas Star Party. Okay, my older brother, okay, look at the prodigious notes he's got out there. He was talking about geology. This is a Tuesday night affair that goes on at the Texas Star Party. These are for the people who may not be real interested. Yes, he does do science. He's a planetary scientist because he has an impact. Oh, everybody else? Yes, I'll get you that. Okay. And we've got Halton Arp. That's Dennis Webb. Jeff is probably in my doghouse. Dennis was first speaker I had at El Dorado Star Party. Yes, we did funny things already. Bring your book, and he goes, bringing up his book he's promoting about Halton Arp stuff. And of course, Angela, and with Ted Saker and the solar glasses, because it's 2023, and then of course, Alan Stern. Yes, it's a date thing, it's not film. Alan has the one thing that I probably cannot do. Alan has the pacing. They redid the hall at the Prude Ranch, and he had the right pacing to make great acoustics in there so everybody could hear his talk. And it was fantastic. Not that Angela's wasn't bad, it's just I was reminded of other things. So, and there's probably a piano back there too, so everybody gets an award. So speakers is El Dorado. This one's a weird one. This is Jeff Barton. I got in trouble for thinking he's Jimmy Buffett. He did not like that. And there's one guy who actually shown up to star parties, and I'm in the doghouse for calling him. He sounds like James Woods. And that's C. Renee James trying to get questions. She's about the last speaker I had. Lindsay was there one time. I couldn't find the picture. Sorry, Lindsay. Kind of the inspiration on that. Say la vie. Wah, wah. Wah, wah, wah. So we do that, and everybody has their stuff. I know some of them, not all of them. So we kind of do that. 3RF is the one thing that's changed. That's owned now by Texas Tech University. So what's our chances of getting up there, Robert? Probably, what? Probably nil, because you probably have to take all the compliance training the rest of us in academia have to take first. Okay. Yes, and life is a playa. 1 year. See, this is the one thing that can happen. Life gets out when you do certain things, and part of it is basically they have playa lakes over there at the X-Bar Ranch, and the problem is that every now and then you get a flood that floods everything. So we had to move our observing field, and this stuff showed up. Of course, what do you do when it rains? What do you do when it rains? No, you see the metaphor? We drink. There's wine tasting. No, the wine tasting only shows up a couple of times. That's for pizza on the one. Bourbon tasting. Watching somebody try to explain three-phase electricity to an IT person. I missed that. And then if somebody else we know who loves his Maker's Mark 47, I swear, man, Rivenberg's baby boy, nothing but the best. And of course, I owe somebody, I know, Interesting Places or A Bridge Too Far. Yes, I took this. That's Highway 90 Bridge. That's the tallest in Texas, so that's US 90 over the Pecos. It's decidedly that way. And of course, I'll go step out, and they still do it wrong. It's not lock up, it's look up. So yeah, it's a 2-lane bridge, so it's fun. So interesting competitions. Uh-oh, that's Dennis Webb. He was a NASA guy, retired from NASA, Houston, and he plays the guitar. Yes, I sang with Dennis. We'll get later. We'll talk about that later. And then, of course, one of our guys, and a reminder of this, that is David Moody, which I'm told I still have to do a search and rescue mission for a $500 bottle of scotch. And as we've talked to somebody else, an astronaut that Robert knows, says the problem is if you take that $500 bottle of scotch and you put the 10,000-year-old glacier ice in your cup, for some reason, that $500 scotch or whatever does not do it justice. So yeah, this is the kind of thing you run with astronauts. So this is kind of the artsy, fartsy side of it. And I've done judge competitions. Robert has got me in. Of course, how did we get to know each other is difficult. Oh, shoot. Uh-oh. That better not be Clayton. Okay, that's Dennis and Clayton Jeter. Okay, this is how all this stuff happens. If it's not a sushi bar, hang up. Okay, our thing is, I sang probably, which one did we sing with Dennis? And Clayton was the drummer. With Dennis, we sang, he does the Galaxy song. We sang Under the Milky Way Tonight. He cannot do that well on it. It's his stuff. Clayton, I was in the doghouse for about 2 years. Clayton was trying to ask our mutual friend, Becky and Shane Rampantowskis, to do an article for the Houston Astronomy place. What did we wind up doing? They said no. They wanted to get Dwight. What is my brother munching on? A chili cheese dog. And my brother responded, I'll think about it. I couldn't let that go. What did I do? I said, I'll tell you what Dwight means by think about it. Sorry, Dwight. I know, he's not here, but he's under the bus. That means I'll never do it. I don't want to do it, and leave me alone. I'm eating. So we kind of did that. So Clayton was mad at me. Clayton does stuff with Celestron stuff, too. He used to clean up telescopes. He says, don't use a Barlow. I'm like, if you've got an 11 or 14, fine. And, of course, this is me. Now, things that show up on these are probably as important as anything. So this is the 2 meter. I know, it's 2.1, but who cares? We're one significant figure. Do engineering. So this is yours truly on it again. That's the back end of that 82-inch. It's the best visual optical large telescope in the country, bar none. To get on this thing is rare. So our thing is, how did I do it? Okay, that's, let me see, Anna and Jim. That's Jim Chandler. Jim Chandler sent me an email. The only reason I got on there because my brother's visual acuity and is able to observe got us points. Otherwise, he would have left me alone. So we wind up on there. It's an English cross-axis, and of course, it's kind of like a old MasterCard commercial. Cost to observe all night, $150. Gas, $50. Not having to close the dome and put up a telescope, priceless. And of course, our thing was, it was Odawan, who was the other one. I can't think of his name. Odawan was the scope driver. So it was a really nice thing. It's rare. I think the only other ones are probably the 60-inch at Kit Peak. So are all these just a bridge too far? That's Lano. That's Lano, probably over there. I crossed over it, but I didn't do it. Okay, I'm repeating as I always do. Okay, up on top. That's Okie and that's Tex. Of the Okie Tex Star Party, that's a picture by Dwight. He went up there and pulled them off the top of the mesa. There's Camp Billy Joe up in there. So it's a lot of things to actually pull out and kind of summarize it. It's like AVSO, IOTA, ALPA, whatever you do. The other thing is AAS has a bunch of spinoffs that they love their pro amateur confabs to where they can get everybody together. Texas Star Party at the Prude Ranch, Deep South Texas Stargaze. Do we still have it on there? We do not have that. Oh yeah, we can. Texas Star Party. Karaoke question. Yes, I have sung karaoke. I was not too drunk to sing it. And the only one I remember doing well enough was the Eagles' Life in the Fast Lane. The only thing I couldn't do is, I'm half Czech, half German. I couldn't sing 99 Luftballons auf Deutsch. It wasn't the drunk, it was no training. I told you, Lisa. So we have the other ones that we do in the giveaways. So a few others are there, and I didn't do anything else on there, and there's other things that are embarrassing with Dennis. I was there one night in the bunkhouse. Oh my God. Jason Ware, sponsored by Mead, comes out. Dennis, can you sing me Soft Kitty? I was like, oh, son of a. So it was one of those deals. It was like, oh yes. So the 12-year-olds show up at star parties. Okay, Nebraska Hills. These are the other ones. There's too much things going on that anybody can go. So the last thing I'm doing, it's the David Lynch part. Laura Palmer wrapped in plastic. Because these are Skywatcher and Mead, and of course there's a little bit of fog. That's Will. Most of the stuff, historic bridges. And then of course the usual thing at the end of a star party is the moon. And mostly my stuff, my brother did other things of the Okie-Tex picture, so we kind of get that. So thank you.
All right, I found the on switch. Thank you, Mark. First of all, I love those flamingos. Those flamingos, I mean, we have...
Okie and Tex.
Huh?
Okie and Tex.
Okie and Tex. Because
Tex.
we have Tex.
Because it's called the Okie-Tex Star Party.
Okie-Tex. Oh, there you go.
Where do you think it is?
What?
The Okie-Tex Star Party, where do you think it is?
At the Oklahoma-Texas border. Okie-Tex, yeah. No, I love those flamingos. We have some at home, and they spruce up the place, as they say. All right, our questions for you. We have the first one. Where'd it go? What is your favorite kind of enrichment?
Ooh. Favorite kind of enrichment? Let's think about this. Probably the best would be more of, I think about the one thing for enrichment is I'm always talking about the professionals coming in when they actually do a good job of the talks. They're usually the ones that are most entertaining, and if they keep it short enough.
What is the most difficult thing about being an amateur astronomer?
Most difficult thing? Trying to tell people there's more things than outreach. That's probably the most difficult. The other one is, aren't you an imager? Don't you image? I'm a visual person. The imaging thing I've dabbled in, so it's just a matter of doing that, and Robert says, come on, you have access to Photoshop and everything, go do it.
How and what do you report for asteroid occultations?
Probably what you do is you usually have one person to collect all the data. See, that's why you keep it in your hip pocket. Collect all that data, and then they wind up fitting it to an ellipse. Yes, there's math involved. They usually fit it to ellipse or something else and try to see how close they get it. And then they report it to the IOTA. I don't think there's a Greek letter with it, but who knows?
Where is the two-lane bridge? Which bridge? Weren't they all 2 lanes?
We can answer 2 of them. The tall one is in western Valverde County. The other one is the bridge somewhere, it's north of Pontotoc. It's over the Colorado, that narrow one. That actually shows up in Texas Country Reporter. So it's actually kind of a famous bridge. It's the only suspension bridge like that. And I can't think of the two counties off the life of me.
Yeah, I'll ask you a question. I guess more on the topic of star parties. You know, if people are interested in star parties, because I know a lot of us in here have volunteered or just attended. How do people actually find out this information, right? Because you're starting pretend like they know no background. How do you find out that it's happening and that you can go?
The problem is, especially stuff like winter skies, you have to be there almost 2 years in advance and get on their websites. Their invites are kind of rough on that. Texas Star Party, some of them you just literally these days you type in, okay, Texas Star Party or Star Parties. Of course, the other place to start out is either Astronomy website or Sky and Telescope, because they typically will advertise all the stuff once a year, and they'll advertise all the places. So sorry for no map.
There you go. Well, that's very helpful. Hopefully, everybody, if you all are interested in star parties, go ahead. It's always a lot of fun. There's a story later. Let me find. What is your favorite karaoke song?
Favorite karaoke? I say favorite karaoke. I did Bunch on the Eagles. I wished I could get something else, but actually fits. I'm wearing the Hawaiian shirt that I should sing when I'm at TSP is One Particular Harbor. And I should do it. and I'm not doing it here. But the one thing about One Particular Harbor is he sings the lyrics in there. He says, I got too much stuff, can't explain the likes of me. So some people can say, I've got too much astronomy stuff. I still have good access to astronomy stuff.
Is that, what is this? Is that Trevor from Astro Backyard in that last photo?
Trevor.
I don't know.
Probably one of these. I didn't meet them. They were packing up. These are either in the black hoodie. Oh, in the middle. He might be Trevor. But most of these guys, it's either Celestron or Skywatcher. And I think he's Skywatcher, if I didn't know correctly.
Very interesting. All right. Let's thank our speaker once again. Thank you. All right. That brings us to the end of the program, but we're not done. For those of you that do have to go, we understand that not everybody can stay. We thank you for coming. We hope you join us again for our next one in March, on March, same day, 5th. For those of you that can stay, we're going to come around with the sheets and pens. Please remember that our max group size for trivia is 4. So if you have a larger group of 4, please split. And we'll get started in roughly 5-ish minutes. Oh, really? You're feeling it, Mr. Krabs? Maybe we can get Michael to drive us.
We can ask.
Name my trivia drink. Trivia. Does everybody who's playing trivia have a trivia sheet and a writing utensil?
Hello. All right.
You got your attention?
Thank you, Mr. Gemar. Sorry, Brittany.
Does everybody who wants to play have a writing utensil and a trivia sheet going once, going twice, sold? If not, too bad.
What? You need one?
Sorry, Brian. Sorry. That's my bad.
I can't.
That's on us.
All right. To go over the rules while we set up, remember, max group size of 4. Please write only the letter for the multiple choice questions, and no cell phones allowed. We want this to be fair. We have some great prizes for everybody tonight. Let's give them out. Without further ado, Aaron, question 1.
Question 1. This centennial in history. In 1925, Cecilia Payne published the most brilliant PhD thesis ever written in astronomy, according to Otto Struve. What was the thesis topic? Was it A, radio astronomy, B, stellar spectroscopy, C, extraterrestrial life, or D, galactic structure? 1925, the greatest thesis ever written. So says Otto Struve. In astronomy. What's the best PhD thesis ever written in any field?
Yeah, that's an interesting thought of when it started.
The origin of man. The origin of man. Charles Darwin? Oh, the origin of species, rather. By Charles Darwin, yeah. (1925). What was going on in the 20s in astronomy? I'm not really sure. I know one of them. What was going on in astronomy in the 20s, the golden 20s? Yeah. 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 And so this is after Hubble, right? This is after. Yeah. Yeah. All right, everybody good on question 1?
Aaron,
All right.
I forgot. We
Oh, yeah.
What's our answer?
I think it's D.
I was between A or D, but
Yeah.
I don't know if you would know the radio people.
I don't think so. Not in the 20s.
No. Okay.
It could be stellar spectroscopy though, because I don't know what the greatest thesis would have to do with stellar spectroscopy and galactic structure though. That's why, I think galactic structure is right after Hubble.
We're the stellar hosts. All right, question 2. This centennial in history. Also in 1925, Masataka Ogawa discovered which new element, which is currently sandwiched between tungsten and osmium in the periodic table of elements. Is it A, rubidium, B, uranium, C, rhenium, D, radon, or E, barachnium, obamium? And bonus, now this is not the bonus, this is a bonus, so I want you to write this next to the letter. What is the atomic number of this element? And since this has nothing to do with the question, well, maybe a little bit, maybe it'll jog your memory. Tungsten is W. For Wumbo.
On the periodic table. And for the bonus, if you're wrong, you're wrong. There's no closeness on this one.
Aaron. All right, good to move?
Everybody good? Question 3. The perfect cube. The year 2025 has gained notoriety for being a perfect square. What? Really?
Aaron, 2025.
That tells me nothing. What is the next year that will be a perfect cube? A, 2026, B, 2072, C, 2125, or D, 2197? I know it's not one of these. I did not notice this. The next perfect cube. I was thinking square. No, the next perfect cube. Sam. That's sam.hart@swear.org. We did our math. Anybody?
Question
need
4. Near-Earth objects, or NEOs. It turns out that the definition of a near-Earth object includes objects that are nowhere near Earth. So another term called potentially hazardous asteroid was defined. At what distance from Earth is an asteroid considered potentially hazardous? A, below the Kármán line, B, within about half of the lunar distance, C, within lunar orbit, D, within about 10 times lunar distance, or E, between the Earth and Mars. Which one of these is considered potentially hazardous? All right. Everybody good?
Question 5. Twinning, the astronomical
We'll come
symbol
back.
shown here belongs to which minor planet? Is it A, Pluto, B, Gong Gong, C, Make Make, or D, Quawar? That's not French. Please tell me that's not French. Oh. Quawar. Quawar.
Wait, maybe it's core.
Oh, it could be core.
Because never forget Quahog.
Yeah. Everybody good?
And we'll come back to them at the end, too. Amateur astronomy, the topic of tonight. The Soap Bubble Nebula, pictured below, was discovered in 2008 by an amateur astronomer named Dave Jurasevich while imaging which greater nebula? We have A, the Crescent Nebula, B, the Horsehead Nebula, C, the Eagle Nebula, it's got an E in it, or D, the Crab Nebula. Which nebula was the amateur astronomer observing when they found this soap bubble?
Get it? Soap bubble.
It's
Looks like a
incredible how much it does look like a soap bubble. Like, that's perfect.
The star could be there. I don't know if we would see it or not. Oh, nice cuboid. I don't want to see these. Do not show me this. All right, does anybody need a question repeated? 3?
3.
Got 1 for 3. 3, we got 3, we got 3.
Did you have one? Yeah. No, not a question.
No,
a question to be repeated.
We don't have qualifiers.
A question to be repeated? 3? 3. We're getting a lot of threes.
There, question 3.
3. The most mathy one.
Do your arithmetic. Do you know your squares? I know them up to 25 because I had to memorize them for school.
I did the math on the paper, and I figured it out.
Cube.
It's right. Where's the...
Perfect cube.
Hello. Hi.
Not an imperfect cube.
We'll leave this one up, but did anybody need any other question? Raise your hand. You'll need 5.
5. 6. Gotcha.
5 and 6.
Okay, well, you know what question 3 is, so find the cube. Find the perfect cube.
All right.
You can write down the answers if you want to know which one is which. There we go. That's
5, for those of you that needed it. Is Pluto a minor planet even though it's old enough to go to AOT?
For minor planet designation, it is 18. No. What? 10? Yeah, 18. It's 18. Pluto's minor planet designation is 18.
For those of you online that were wondering why we mute between questions, it's because Aaron and I are deliberating answers, and I don't want to even give you people at home a leg up.
No crosstalk.
Sorry.
No crosstalk.
But not sorry.
We have our own trivia going on up here, but we don't win prizes.
That's why I'm having snark.
Richard, how do you even know we're muting? That's right.
Well,
I called you out. Oh, question 6. Question 6.
Yeah.
All right. When you are done with your answers, can you please bring up your trivia sheet and your writing utensil? Oh, whoa. Getting ahead of myself tonight. That's the second time.
Yeah, well, we still have the bonus. But we wanted to get all this out of the way first.
What's a PHA? Yeah, sorry. We have a bonus question. I apologize. We have the proper bonus.
PHA, Cody, not a PAH.
What's a PAH?
Polyaromatic hydrocarbon.
Oh, jeez. Polycyclic aromatic hydrocarbon. Come on.
Even worse.
Why is it aromatic? I can't smell it. We can't go there. Words.
All right, is everybody good with every question? Because we want to go to the bonus. Because tonight's is a doozy.
I will preface this with for all complaints, samuel.hart@sweary.org. All right. Go ahead, Michael.
Wait. Which one of us?
All right, you're the 48th president, and USA has just landed the first American on Mars. For no particular reason whatsoever, you signed an executive order changing its name. What name do you bestow upon the red dot? The most creative answer is given 1 point. You may justify your answer. I don't know why. If you have to justify your answer, that's too much.
To be fair, you do have extra lines for the justification. But remember, it's Aaron and I are the judges here.
Yeah,
so,
we're the judges. We're the judges of most creative.
I'll leave the mic on.
When I read this bonus, I thought, Gulf of America. Why not? Thank you. I really hope so. I don't think no one probably will, but I would put America Part 2 Electric Boogaloo.
Yeah, that's a good one.
That's like just right off the. That's like immediate. That's like low hanging fruit.
I would want one that's red focused.
Red focus.
Yeah, so like
The Red Baron.
the Red Baron, yeah. Rouge.
Rouge.
The Moulin Rouge.
The Moulin Rouge. Oh God.
Oh, yeah.
Thank you.
Mars.
Sure, it would be so.
That would, nah,
Brain cells get in the mind of Donald J. Trump.
yeah. Oh, God. No, you're the 48th president.
Once again, when you are finished with all your answers, please bring up your trivia sheet and your writing utensil if we gave you one, and we will grade them and get back to you with answers and prizes.
Okay, where's the... Shoot. What was that?
Careful behind you, there's a wire.
Don't cut the wire. Wait. Thank you. Hold on, I want to see how we did. I want... What? Oh my God, we only got 2.
Which two? I don't remember.
3 and 5.
That's terrible.
Okie dokie. Answer time.
All right. What was the topic of the greatest PhD thesis ever written according to Otto Struve?
Hey! All right.
He did it. What is the greatest thesis ever written according to Otto Struve? The topic? It is B, stellar spectroscopy.
And
I want to know why.
I'm going to presume that this is a figure from the paper? No? Oh.
No, good Lord, no. Not from 1925.
Yeah, because they didn't have color then.
Exactly, it was black
They could
and
have
white.
manually colored it in.
We didn't have color until the 70s. Life in living color. I mean, come on.
Yes, the human eye could not comprehend color until 1960.
Yep.
All right, there you go. The spectroscopy determined that the sun was hydrogen and helium, which was a very important discovery in our field.
Oh,
Temperature, very good.
I get it.
All right, our second question, which is about which element was between tungsten and osmium discovered by Masataka Ogawa, and the answer is C, rhenium. And the atomic
why?
number of that is 75.
You know why it was called rhenium? Rhenium?
I told you it was in the 70s,
Yeah, you were right.
but I didn't get the element right.
I have a complete misunderstanding of the periodic table of elements. A complete misunderstanding.
There you go. So that was rhenium 75. All right.
Did everybody do their arithmetic? No? Because it was 13. 2197. Perfect cube. Do the math.
This is, wait. Fifth, sixth grade math?
Is it?
So if you didn't get it right.
Damn. Damn, he called you out. That's just. Ow. I mean, it is just multiplication.
Yeah, I know. That's why I say it's just multiplying numbers. Okay. Question 4 about the near-Earth objects, and more specifically, the potentially hazardous asteroids. Much to Aaron's surprise, it's a vague description because
I got
it's
beef.
within about 10 times the lunar
What does that
distance.
even mean? Like about? 9. What do you mean? What do you mean you rounded it?
Uh-oh, here we go.
0.05 AU? That sounds like an exact number to me.
Once again, we have...
On this same note, like I literally am writing a proposal about this, but NASA, I think, has one of the stupidest definitions for a near-Earth object. It's something that comes... a near-Earth object is something defined as its closest approach to the sun is 1.3 AU. But you could have like an eccentricity of like 0.9. Go all the way out to Jupiter. What? Like that makes no sense. Like you're nowhere near, like, whatever. But relatively speaking of the universe, yes. But like, that's not my near. I wouldn't say that's like, that's over there, you know?
Well, and this
Mars
is
is 1.7, so like, whatever.
And this is why they needed the new criterion of a potentially hazardous asteroid. What do you mean?
Is it the Moid? Is it?
Oh, I would imagine that what that distance is the closest it'll appear to Earth.
What do you
No,
mean?
because it's a lot closer to the Earth than 1.3 AU.
No, a near-Earth object is defined by its orbit. A potentially hazardous asteroid is defined by its distance from Earth, its closest approach to Earth, I'm assuming. I would think that's what it has to be, which is definitely. So it's still stupid.
Yeah, but yeah, if it Yeah, sorry. We're all just waiting for Apophis anyway.
And 2024 YR4. Make. I thought it was Gong Gong. Well, I thought Make was the one that JWST observed with the rings. That's what I thought, but...
Well, the logo looks kind of ringy.
Looks like Squidward.
Yeah. Wasn't that Characlo
Huh?
with the rings?
What?
Wasn't that Characlo?
I don't know what you mean.
No, I don't know.
Yeah.
Well, maybe. Maybe they both have rings. So the sixth question, oh darn, which was about that soap bubble. Which nebula was the soap bubble a part of? And the answer is A, the Crescent Nebula. Very, very good.
If it makes you feel any better, Michael and I got 2 right.
Yeah, we did not do well tonight.
I thought this was the
It was
Eagle
a rough
Nebula.
night. It was a rough night, but we blame Sam for one of them.
Yeah, I'm emailing Sam tonight.
But no, these were good questions tonight. Thank you, Sam. And thank you all for participating. Now we get to the fun part of revealing the prize winners. So as far as the bonus is concerned, our vote for the most creative answer is Covfefe. A classic from the 45 era.
Honorary mentions, Lance Armstrong's missing ball. And then on that note, Ligma.
All right. Our third place winner tonight, everybody on the team is going to walk away with the Night Sky Almanac from 2024, but remember, a lot of interesting stuff in it regardless of year, as well as some stickers, Juno stickers, which I think we'll find out soon if it gets its mission extended or not. Yeah. The winner of third place is Las Estrellas. Where are Las Estrellas? Come on up. Woo! All right. Our second place winner will win a English and Spanish NASA official calendar. Show them off, Aaron. Show them off. Really pretty. There you go. And more Juno stickers. And the winner is Treasure Planet. Woo! Enjoy the calendars. They're very nice and they're hard to get, so treasure them. Well, that's in your name. All right. Drum roll, please. The first place winner of the second to last Lunar Orbiter prints are Star Masters. Oh my goodness. Wait, you forgot. Aren't you running out of room for the prints, Caleb? Yeah. Yes, you know. He's going to have a moon room in his house someday. Just watch. All right. Before we sign out, if anybody borrowed a writing utensil from us, please bring them back. We keep losing them each time, so we value when you bring them back to us. All right. As always, thank you so much for coming. Thank you, Simon. Our next AOT will be exactly a month from today, on March 5th. We already know we have one speaker confirmed who will be talking about ring science. Very interesting stuff. Be sure, if you haven't already, sign up for our email list. Thank you to Swiri, UTSA, and of course, the Blue Star Brewing Company for hosting us each and every month. Good night. Get home safe.